Hello everyone, welcome back. So this is a continuation of our first principle review. So before we begin, don't forget to like and subscribe. Alright, so let's get to it. So I've been told that f of x is equal to sine x. This is one of the questions that have been asked by most people to solve, so let's solve it. So we're going to apply the same knowledge that we applied in the previous examples. If you didn't watch the examples, kindly also go back and watch those examples. Alright, let's start. So using the first principle, I have to use the first principle equation, which says f prime of x is equal to lim as h approaches 0 of f of x plus h minus f of x over h. After that, all we need to do next is to collect data. So we say data, look for f of x. F of x is what we've been given in the question to be sine x. Then also look for f of x plus h, which will be basically sine x plus h. So it's a bit proper that we write these two values of f of x and f of x plus h in this manner, where we say sine of x and sine of x plus h. Alright, after that, all we need to do next is simply to plug back. So if we plug back, we have f prime of x is equal to lim as h approaches 0 of f of x plus h, which is sine x plus h minus f of x, which is sine x over h. Alright. So after this, all we're supposed to do is to remember that whenever you have sine x plus h, this simply just tells you or shows you the identity of angles sum. So this is showing us the sum of angles. So remember, let me just give you a quick review. If you can recall, among the identities we have sine a plus b is equal to sine a cos b plus cos a sine b. So using the same knowledge, this implies that f prime of x is equal to lim as h approaches 0 of sine x plus h, which will now be sine x cos h plus cos x sine h. Then it will be minus sine x, and this will be over h. Then after that, we can put together the signs, the trig ratios having sign. So we'll put this and this one together. So we say f prime of x is equal to lim as x approaches 0 over sine x cos h minus sine x plus cos x sine h, and this is over h. Then after that, we can factor out the sine x. So f prime of x is equal to lim as x approaches 0 of sine x, write this properly, sine x. So this will give us, factor out, we get cos h minus 1 plus cos x sine h over h. Once we do this, we'll have this portion here. So we can't plug in directly. So what we're going to do is to now split the single fraction into two fractions. So by splitting it, we'll have f prime of x is equal to lim as h approaches 0 of sine x cos h minus 1 over h plus cos x sin h over h. Then the next thing we can do is to just pull out the sines and the cos. So what I mean is that I want us to simplify it in the manner where you have sin x alone, so that you can have cos h minus 1 over h. Then plus you pull out the cos, so you have cos x times sin h over h. Then once you have this, you can now apply the limit property. So we'll apply the limit property of the sums first. Since it's a limit as h approaches 0 of this, we'll apply the sum property. So f prime of x is equal to lim as h approaches 0 of sin x times cos h minus 1 over h plus lim of h approaches 0 of cos x times sin h over h. After this, we can apply the product property of limits. We'll say f prime of x is equal to lim as h approaches 0 of sin x times lim as h approaches 0 of cos h minus 1 over h plus lim as h approaches 0 of cos x times lim as h approaches 0 of sin h over h. Now remember the limit identities we have. If you can recall, just to review, lim as h approaches 0 of cos x minus 1 over x is equal to 0, and lim of h approaches 0 of sin x over x, or x over sin x, is 1. So applying that property, let us distribute the limit. This implies that f prime of x is equal to, now limit as h approaches 0 of sin x. Now h has nothing to do with sin x, so the limit as h approaches 0 of sin x will just be sin x, because it's not sin h. So you have sin x. Then the limit of this portion here is the identity that we have here. So lim of h approaches 0 of cos h minus 1 over h is simply 0, so we say times 0, plus the lim of this guy here. You find that h has nothing to do with cos x, because it's x and not h. So the limit of that will just be cos x. Then this will be the limit identity that we have here, which will give us basically 1. If we follow this, f prime of x will be sin x times 0 will be 0, plus cos x times 1 is cos x. Therefore, f prime of x is equal to cos x. Alright, thanks for watching. See you in the next problem.